Hello everybody, it's Mr. Williams again, and today we're going to look at another different little mini lesson. And today's mini lesson is going to be on atomic structure and symbols for both atoms and ions. And it's extremely important to remember that when we're talking about these structures and symbols, we're going to look at atomic number, we're going to look at mass number, and how charges affect the number of those subatomic particles within the atom. Now, here you see three different symbols, and let's first analyze the carbon symbol to start. What you will notice that in all three of these symbols, the lower number on the left-hand side, that number is considered the atomic number. And the atomic number is equal to the number of protons in an atom. And if you think about it, since all atoms are electrically neutral, we can also say, and electrons when neutral. And it's always the starting point when we look at ions. This second number, this one on top of the atomic number, is considered the mass number. And the mass number indicates the number of protons and neutrons in the atom, because those two particles are the most massive. They are over 1,000 times greater in mass than an electron would be, and thus we kind of think of the mass of an electron to be 0 AMUs, whereas the mass of a proton and neutron are both 1 AMU. If there would happen to be a number in this location right there, that location would indicate what the charge of the atom would be. All right, if there would happen to be a charge. In this case, there is no number listed, so this one is neutral. But if there is a positive charge, that means that they have lost electrons in the atom to become a cation. And if there is a negative charge, they have gained electrons to the atom and become an anion. So it's extremely important to look at those three locations when trying to determine what is the structure of that atom. So if I was to ask, for example, how many protons, neutrons, and electrons would be in this carbon atom, since there are 6 for an atomic number, we know there are 6 protons. Since it is 12 for our mass number, if we take 12 minus 6, that equals 6, so there's 6 neutrons. And since there is no charge, that must mean there are also 6 electrons for the carbon. Now, below you see both a cation and an anion. Again, the nitrogen is the anion or nitride ion. The potassium is the potassium ion, or is a cation, and we know those because of the charges that are shown. The nitrogen having a 3 minus and the potassium having a +1. If I was to look at each of these and say how many protons, neutrons, and electrons would there be, it's still very similar. Since nitrogen has an atomic number of 7, we know automatically there are 7 protons. Because the mass number is 14, 14 minus 7 is 7, so this would also have 7 neutrons in that ion. The difference comes when you look at the charge. Since there is a 3 minus charge, we start with the 7 electrons, but since negative charges gain electrons, therefore we're going to take 7 plus 3 and get 10 electrons for the nitride ion. Potassium, the cation, is just the opposite. Similar to start, we know that first off there are 19 protons because the atomic number would be 19. We know if we take 39 minus 19, that gives us 20 neutrons for that ion. And lastly, since it is a +1, since we're starting with 19 electrons, but positive charges lose electrons, 19 minus 1 would give us 18 electrons total for that ion. Now, this symbolization is one way we can create a symbol for atomic structure. Another way is the hyphenated symbol. And so if we look at a hyphenated form, it's important to remember that the element is neutral. It will first give you the name of the element, and it's going to be the full name of it. And then this 4 represents the mass number of that element. Again, that is still protons plus neutrons. Question arises, how do I figure out how many protons it would have? Well, I have to remember that I can always use the periodic table. And since helium has an atomic number of 2, it has 2 protons. 4 minus 2 would give us 2 neutrons. And since these are always neutral, it would also have 2 electrons for that specific isotope of helium. Those are your 2 symbolizations and how we use them. So what I have for you now is I have a little chart for a practice problems. I'd like you to try that out, and then I will actually go through and put in the answers, and you can check yourself here in a couple of minutes. So I hope you've enjoyed this little mini lesson on atomic structure. Good luck, and we'll talk to you next time.